Hi Space Cats and welcome back to my channel. Einstein's theory of gravity states that nothing can travel faster than the speed of light in a vacuum. But what if I told you that that isn't exactly true? In this week's video, I'll be talking about Alcubierre drives. So let's get to it. So prior to the 1600s, people believed that light was instantaneous. And then Galileo came along, and he was one of the first people to think that the speed of light was finite. So he did a pretty stupid experiment. He went to sit on a hill with a lamp, and he got his assistant to do the same on the opposite hill. His idea was that he would reveal his lamp, and as soon as his assistant saw it, his assistant would reveal his own lamp. The time between Galileo revealing his lamp and seeing the assistant's lamp would be recorded, and the distance between the two hills was known to him, and that would tell him the speed of light. Unfortunately, the distance between the two hills was too small, and Galileo concluded that light was really fast. Since then, however, other experiments have proven Galileo correct. The speed of light is indeed finite, and it's approximately 300,000 kilometers per second. In Einstein's special relativity, the faster something travels, the more time slows down. This is a phenomenon known as time dilation. At the speed of light, however, time stops altogether, and so nothing can travel faster than the speed of light. In general relativity, this is still true, but more specifically, it says that nothing can travel locally faster than the speed of light. From this definition, we know one obvious example of faster than light travel, and that is from the early universe. Shortly after the Big Bang, during the phase called inflation, the universe expanded at faster than light speeds. But space isn't really anything, it's nothing. And the speed limit only really applies to things within our universe. The inspiration for the Alcubierre drive stems from this use of the expansion of space for faster than light travel. An Alcubierre drive is a concept that was proposed by theoretical physicist Miguel Alcubierre in 1994. The idea is that by modifying the geometry of space-time, the fabric of space and time, by compressing the space in front of you and expanding the space behind you, a spacecraft would be able to sit in the flat space in between the two, known as a warp bubble, and essentially surf on a tidal wave of warped space. This would allow a spacecraft to accelerate to faster than light speeds, and all the while everything inside the warp bubble would still be limited to the speed of light. Alcubierre also showed that within the flat region, the spacecraft would not suffer any time dilation at all. In other words, time would pass the same as usual. And as he showed that as long as the radius of the warp bubble is larger than the spacecraft, it would be possible to design it such that the spacecraft wouldn't experience large tidal forces that would rip it apart. Just like with warp drives, Alcubierre drives are driven by exotic matter, so non-normal matter, and in particular matter that can give us negative energy densities. Given this, then the tidal wave can travel faster than the speed of light. Miguel's proposal, unfortunately, would require huge amounts of positive and negative energy to expand and contract the space-time fabric. But by modifying it into a warped donut instead of a warped ring, you could reduce the amount of energy needed. But would it actually work? Well, the Alcubierre drive is fully consistent with general relativity and Einstein's field equations. The drive shifts space around an object so that the object arrives at its destination faster than light would in normal space, but it doesn't break any physical laws. So in principle, yes, it could work. However, we are still missing one key ingredient, and that's exotic matter. But is exotic matter real? Well, in quantum field theory, there are examples of the existence of negative energy densities. Unfortunately, however, quantum theory and relativity still don't really get along with each other. All of this sounds like science fiction, but there are several researchers that are actually taking this concept seriously, and they're actually looking into turning Alcubierre drives into reality. Thank you so much for watching this week's video. I hope you found it as fascinating as I did, and if you did, don't forget to leave me a like, share, and subscribe.